Okay.
Welcome, everyone. This is Juan Soto, the chapter leader for Access with SQL Server. We have a very special guest tonight with a wonderful topic for you guys. Before we get started, I'd like to remind you, if you can please mute yourself and use, if you have any questions, I ask that you put it in the chat or wait until the end of the meeting where we have the open mic section of it. Before I introduce our special guest and topic, I do have a couple of news to share with you guys. First off, I finished the European Access Conference last week. It was an amazing conference. Those recordings are now available, so please take a look at it. If you were a conference participant, you are entitled to see the recordings. If not, then hopefully you'll catch the next one. I had really good feedback from all the participants. I usually don't fare well with the surveys and the European conferences, but this one really I really did good, so I'm happy about that. Hopefully they'll invite me again next year again to talk more about consulting in general. And we got some good new features in Teams. I urge you to look it up. It's all over the web, all the new features in Microsoft Teams. So if you use Microsoft Teams at work or thinking about using it, please take a look at it. Thank you, David, for that wonderful comment. Appreciate that. And then this is our last session before our summer break. Our summer break is June, July, and August. So we'll be back in September with a new set of great topics, which I like to get your input. Usually what we do is September, October, November, we do SQL Academy version, part 1, part 2, and part 3. But I've done that so many times already. And there's so many recordings of it. Maybe you guys are interested in other topics when it comes to Access with SQL Server. So shoot me an email at jsoto@itmpet.com. Tweet about it at jsoto22. Follow me on LinkedIn at linkedin.com/n/JuanSoto. And let us know. We also have a group, LinkedIn group called Access with SQL Server. You can also leave feedback there. All right, so let's get to tonight's special guest. She is an amazing woman. I admire her tremendously.
Who's she?
She started with IT Impact, going in now on 7 years, 5 years, 7 years.
7 years, yes.
7 years, yes.
7
And
years.
so she is originally from the UK, and she's actually from there right now. She's there right now visiting family. So it's 12:30 in the morning. So I really am appreciative of her coming on such early in the morning, such early time. So she is a senior access developer for IT Impact, senior access consultant, excuse me. There's a difference. I talked about that before. And she is Susan Pyne. So Susan, welcome.
Thank you. Good evening, everybody, or early morning for those of you in the European continent.
All right,
Okay.
so take it away, and I will mute myself. And then, unfortunately, I won't be able to stay for the whole thing, but I'm looking forward to the recording.
No problem. Okay, well, I did actually speak on this topic a couple of years ago, and yesterday I was listening to the recording of it, and it wasn't very good quality, the recording, so I'm hoping tonight will be a better result. And basically what I'm going to go through is the encryption of data in SQL Server for column encryption, not the whole database, just a column. So when you have a client that's got maybe a column of data that's got social security number or something like a credit card number or something that they need to be really careful with, then this is where the column encryption can come in really useful. I'm going to show you how to handle that on the SQL Server side, and then how we manage viewing and editing that data in Access. Okay, so those are my details. If you've got any questions at all, please feel free to reach out to me or Juan. He'll be happy to answer questions too. And I was hoping Ben Clothier was going to join us today because he's a bit more technical on the SQL Server side. So if you do have any questions that I cannot answer, I will take note of them and get the answers back to you. Okay, so basically what is encryption? And I need to move this image down because it's blocking my screen. There we go. So it's a process of transforming and altering the data using keys and certificates in SQL Server to make it harder for other people to read your data and make it more secure. So basically, it's going to be like a hierarchy level. I'll go through the hierarchy shortly, but it's a level of processes to protect the data. And so if you take the database away and you don't have those other levels of security in, they cannot access the data and it just basically becomes useless to them. So it enhances the security of your data if it gets into the wrong hands. It's recommended, as I say, to implement encryption in data that is exposed over a public network or has high security that you don't want others to get hold of. So the encryption types in SQL Server. So you have asymmetric keys, and those use two keys. One is a public key to encrypt the data, and then the private key to decrypt the same. That is asymmetric. What I'm going to show you tonight is a symmetric key, and it's basically the same key used to encrypt and also decrypt the data. So it's much faster, but still secure. We also are going to be using a certificate. Now I'm going to be showing you the method to use a self-created certificate, but you can also purchase the SSL certificates where you can purchase those from a third party. And it all depends on the companies and what their protocol is. So you can do one or the other. One thing I want to point out is with a third-party certificate, they will have an expiry date, and when you reach that expiry date, the certificate will become invalid, and so your data, you won't be able to decrypt it. But with a self-signed one, it doesn't actually acknowledge the expiry date, so it will continue to work within your SQL Server. And then we've got the transparent data encryption, where it encrypts the entire database. But as I say tonight, we are just going to use the column-based encryption. That is the Transact SQL functions I'm going to show you that allow you to actually view then your data from the columns. I'm going to show you a function to decrypt it and store procedures that allow you to encrypt and decrypt your data. So key-based encryption in SQL Server. How this works, you start off with a service master key, and the service master key is actually generated on your initial installation of SQL Server. The way it actually works, there's actually a level above there, which is actually your Windows. When you install Windows into your computer, there's also a key in there which works with the encryption. Then you install SQL Server, and that has the service master key, which is unlocked by your actual instance of Windows. And then working down, then we work onto the database master key, which is the symmetric key. I'm going to show you now how to create that, and the certificate. Okay. This is what we're going to cover tonight. We're going to cover the encryption hierarchy, how to create keys and certificates, how to change your schema and encrypt your data, and then how to follow decryption and encryption of data using stored procedures and a function as well. So before we proceed, I'm just going to show you this. This is the encryption hierarchy. So as you can see here above, this is the Windows operation system level, data protection, the API, which I mentioned you have first of all. And then you have your the master key, which is created when you actually install SQL Server. And then the route I'm going to follow is this one here on the side. This other arrow for the EKM module, that is for later instances of SQL Server that I'm not going to cover tonight. I've got an earlier instance. I'm actually using 2016 SQL Server. So what we will do is we will create the database master key, which is in the actual database that where we have the data to encrypt. I will create the certificate and the symmetric key and then encrypt the data. Okay, and these are just some links that I will provide to you later on. And these links where you can get a bit more information on what I've covered today.
Hey, Susan, real quick, I just wanted to intercede here before I go, and that is, it's so important that you not only advise your clients, right? Because sometimes you'll walk into a situation like I have, and they have credit card numbers that are not encrypted, they have social security numbers that are not encrypted, they have confidential information. And, you know, one of the first things I tell them is, does everybody in your organization need to see the full social security number? I have a client that I asked that question. Oh, yes, everybody here needs to see a full. So can you guys get away with the last 4 digits of the social? And it's really bad that they're storing this confidential information in Access, right? That's usually the issue I'm coming across. Because Access is so easy to rip off. You can just copy a file to a USB drive, disconnect it, and you're gone in the wind with the address, social security number, and off you go to open credit card accounts or who knows what with the information. So when it comes to securing the data, there's a second aspect, which is retention policies. One of the clients I used to have, she had credit card numbers from years ago. I'm like, come on, man, you don't need to store credit card information from 5-10 years ago. Most likely that stuff is no longer active. But you need to help your client understand that there's a retention policy. So before you go and make social security number a required field or credit card number is a required field, you may want to consider making it optional so that you can blank them out once they're no longer relevant. That's my 2 cents. Sorry to interrupt, Susan. Go ahead.
No, you're right, because that's actually how I started on working on this, is because of the few clients that we had that were actually storing the social security number in the database. So that's where
Yep,
it
I
all
remember.
started with. Yeah.
Okay, thank you.
Okay, so this is my code, and I've got all notes in here because I was planning on sharing this script then with you guys so that you can follow then afterwards the process. Now, I mentioned first of all about the service master key that is installed when you install SQL Server, and this particular line of code, if I execute that, that will actually show me the service master key that was installed during the process of the installation of SQL Server. So I can see that that's there. It's good to run that code first just to make sure it's there. If it's not there, then you will have to create it yourself. And I do have some code to create that. I can share that too. I don't actually have it in this particular script. And then the next step is we're going to create the master key encryption with a password within the actual database where we're going to encrypt the data. I put a pretty basic password in here for this example, but it really needs to be a more complex password. And of course, you'd need to keep that in a safe place so that you have that in future. So I'm just going to run that code. And that has created the master key encryption password. The next step is the certificate. And this is the self-signed certificate that we're going to create. Okay. And as I mentioned, this is the certificate that you can either create yourself or you can purchase it from a third party. all you really need when you're creating the certificate is the certificate name and a subject. That is all that's needed when you're creating a certificate. There is an expiry date. Now, and when you're creating a self-signed certificate, it automatically sets the date just 1 year from creation. I prefer to just add this expiry date 10 years in the future and include that in there. It is not actually required because with a self-signed certificate, because of the way that works on SQL Server, even if you pass the expiry date, it still continues to function at the moment. Yeah, I don't know. Things are always changing. They may change that in the future. But at the moment, a self-signed certificate, although it's got an expiry date, it doesn't actually expire. However, with a certificate purchase from a third party, that will expire on the expiry date, and then your data is useless and you can't get to it. So as I say, I just prefer to create it 10 years into the future just to cover in case anything changes within SQL Server. So I'm just going to run that code. And that is the certificate created.
Hey, Susan, just to interrupt, Ben is here. Ben Clothier is here, so I want to acknowledge that.
Oh, thank you very much. Hi, Ben. Thank you for joining us. So, and now the next step is the
Hello, Ben.
The asymmetric key, and this is the key that is used for both encryption and decryption of your data. So you need to use this key when in your stored procedures to actually read the data afterwards. So I'm just going to run this and execute. So those are all created. So if I go now to my database, we'll now see in the security section, to refresh. And now if I go under my certificates, we see that my certificate's there that I created and my symmetric key. Okay, so now that all that's in place, the next step is to then create a column to store the encrypted data and then create the procedures to view the data. So it's a real simple process. And I'm going to start off for your data that's going to be encrypted, it must always be a varbinary field. I'm doing it at 255. Some people do it at varbinary max. But when I did a sample earlier, I was using max, but then when I looked at the data, the length of the encryption was only like 70. So I thought, oh, let's do it then with a varbinary 255. So there I have created the column that will store the data. And the next step is to encrypt the data. So just now I've created the column. Let me just refresh the IntelliSense so that it acknowledges that that key column exists. Great. Okay. Now when you are encrypting or decrypting the data, it is important that you open your symmetric key to actually run the process, but then close the symmetric key at the end. If you don't close the symmetric key, it will keep the symmetric key and certificate open during the instance that you are logged in. So it leaves basically the data unsecure that anyone can can access it, decrypt it. So that's why it's always important to close it when you've finished, just to keep that security there. So what I'm going to do in here is I am just moving the data of the social security number as I have it in the database into the new column, and I am encrypting the data. Okay, so now in my next step, I'm going to show you, I'm going to read the data. I'm going to show the social security number. This is a social security number I was encrypting. I'm going to show the original data, the original column. I'm going to show you it as it was encrypted, and then I am going to use the code to decrypt the data, just to verify that we have everything as it was originally. Okay, so this is my original column. This is how the data looks encrypted. And then once it's decrypted, you're seeing the number there. Now, this is not exactly how you will see the data in Access, and I will show you that shortly when we move to Access. Okay, once you are happy and comfortable that everything was fine, working fine, we will go ahead and we will drop the original column with the social security number, because the idea is to have it secure, so you don't want it still there in its original form. So I'm going to go ahead now and drop that column. Okay, so now we've got our data there in, see the table. Okay, so we've got our data here, basic information regarding the person, and the social security number encrypted. That's great. The SQL Server side is all good, but now we want to be able to view that information in Access. There are going to be cases where you want to see the whole number, and there are going to be other cases where, as Juan said, there's going to be some users that just need to have access to the last 4 digits of the data. This was a bit of script I added in for how you can insert data through SQL script to add a record and encrypt the data. So here I've just got the script to insert a new applicant, first name, last name, and just the social security number, and this is the script that would run to encrypt the data. So if I just run that, that has inserted that information. So now if I go back up here to view the data, and I've dropped that column, the original, so I'm going to take that out of here now. And run that script, and we'll see at the end. Sorry, and this was the new record that I added, and we can see that it's got the same social security number that I added. If we scroll down, yep, 123378965. Okay. Now this is all working well because I'm the person that created the database and I'm running this code. But you're going to have instances where there's going to be other users that need to use or read the data. They may need to run stored procedures or functions, and you may need to grant them access to the symmetric key and the certificate. And these are the scripts that you'll need to run to grant those. And you just put in the username. Now, Ben, can you just confirm here, if you have a group of users, can you do the same for a group?
Yes.
Yes.
Yes,
Okay.
you can do the same for a group.
Okay.
Yeah,
That's
all the
wonderful.
time. It's the same.
Okay. Thank you. Okay. So now we have the procedures to allow us to view. And this one is to decrypt the social security number. And in this case, all I want to show is the last 4 digits of the social security number. So basically, obviously, if the social security number is empty, then we just return an empty string. Otherwise, I want to start off with the X's to block out the first digits of the letter, and then I'm basically just adding on the last 4 digits of the encrypted social security number. And there we go. So that is what is going to give me. Then I can read here the social security number. Likewise, if we want to see the full social security number, I just done the same here, but instead of putting taking just the last 4 digits, it's going to give me the full social security number. And those are stored procedures that I have set up to use within Access, and they're used within a pass-through query. Okay, and this is actually a procedure that is created to update information. So if a record is updated, what I'm going to do is I'm going to pass through the applicant's ID and the social security number in full as a string here, a variable, and then it's going to convert those and encrypt the data to store into the database. So let me go to Access now and just click on my form. And as you can see, this form is returning to me just the 4 digits for the applicant. The way I've designed this form is if I put it in design view, I have a subform that is using all the other information of the applicant, and that is using the table as its data source, so it can still be edited. But the main form itself is using a pass-through query, and that is what is returning the social security number with just those 4 digits. So we can handle updates to all of the records for the applicant within this subform, but to manage modifications to the social security number, the way I do that is when a user double clicks on the social security number, it opens a single form that will show their social security number in full. They can then modify the number, and the save process then is running the other stored oh, don't do this. God, what have I done? I tested this. Applicant social security number, invalid column name. Let me check my procedure. I think it was because I dropped that column, and I think there was still something using it. But what it should do is use the... Okay, let's go here into design view and we'll troubleshoot what's happening there. Okay, so when I click on save, so that's using my execution and the check for a social security number. Okay, so yeah, what's happening first of all is it's going to check as well if that social security number exists. So maybe there's one of those stored procedures that's still using that field that I dropped. This was one of them that it's using. Oh, that should be okay. Here. We'll ignore that. Okay. That doesn't need to be there. Take the comma off. That's fine. Okay, so let's go again. So now if I go on here, and then it's saved the number as it is. As I mentioned, I'm using pass-through queries. Okay. So there you go. This is a query. This is how we're seeing the encrypted version. And then this is decrypted with just the last 4 digits. And this query is showing me the full social security number. Now the difference between the two queries, I've opted to use only the 4 digits when I have other information for the individual, such as date of birth and their full name. And when we're going to show the full name, I prefer just to have the applicant ID, just for a bit more security, because they then have to look up, oh, so who is applicant 1 to match up the full social security number. That is it. One thing I did want to mention, I have as well in my script here, it's not on this one. I did have it, the function. Oh, that's on. No. Okay. So I actually include script here as well that includes a function. Now this function will decrypt the data so that then you can create a view and use the function to actually run the decryption of the data. So if I now run that select statement with the function. Oh, cannot find. Maybe I need to create the function. I've not created that, sorry. Okay, and now. Now you can use a function, and that is a method that you can then use a SQL view if you need to have a continuous form to show a list of records, as opposed to the single record format that I showed you earlier. One thing I have found out, however, is that using a function is slightly slower to return the records, but it does still work. Okay, does anybody have any questions?
Oh, this is Ben.
Okay, I've seen everyone now. If anybody has any questions, you can unmute yourself.
Yes. Do you have, by chance, an idea how to working with that security numbers in the practice? If you have special groups of users using it, and only one or two groups are allowed to do that. Did you get my question?
Not quite sure. Are you saying that if only a few groups are allowed to view the data, or restrict a
Yeah, I
certain
mean
group?
that you have, like in practice, some people of the personal party may use or may edit the description, the decryption numbers, and others only are allowed to see the last four digits.
Okay, yeah. In those cases, I have used restrictions within Access themselves. Within Access itself, obviously there's stored procedures, and you can grant just certain stored procedures to some users, to one group, and others to another group. But then within Access, we have as well the ability to lock forms, so that where I was on the form to view the participant, I can set it so only admin or certain people can, say, double click there to see the full screen. Not all users can double click there and see the screen.
Thank you.
Okay.
And also, this has been one more thing I wanted to add to that. In general, I suggest that we always use the save process for encryption or decryption, because we have more control over who gets the permissions and who's running and who's saving things. And that's easier for us to limit access through the save procedure. And in theory, when we give that permission to users, the key person themselves, they would have to encrypt or decrypt directly. And I don't really like that idea, because then it's kind of confusing who's doing what, and it's sort of vague. So I think it's better if we just use the through save function, and that avoids mistakes and any holes that, anything missing. Does that make sense? Was that clear?
It was to me.
Yes, thank you.
Great.
Does anyone have any questions regarding on the SQL side, regarding the certificates and keys? Has anyone found this, that it could be helpful to them? Would they be interested? Would you be interested in getting the scripts?
I hope that we get the scripts. That would be most helpful.
Yes, of course. Yeah, no, I will make them available on the Access User Group website. I will paste a blog post with details and the scripts. Okay.
So
if there's-
the suggestion of Ben was never use a bound, but always use unbound and do it separately. The form. Always unbound and save separately.
Yes, I believe that's what. Yeah, as that is what I have. If I
Yeah, it's important that the users will save it on a separate form. Unbound, yes, definitely. It's way more simpler that they will be able to look and encrypt it there at the encryption and then save it in a form. That way that they'll read it only. I think it's fine if they see it in the form, in a bound form only, so that when they read it, it'll be for read only. And the form will require more codes,
yeah,
more
so
lines of code.
So like I have here,
So,
this is I've put the form in design view, which I have for editing the data, and as you can see, the cell is unbound where it actually shows the security number, and it's when they click the save button, they have the code that runs the scripts to update. And on this one as well, I've got code as well. They wanted to validate that there was only one entry to make sure there's no duplicated applicants or social security numbers. So I have extra code there. But this is the actual code then that's actually encrypting the social security number that they've created.
This is Wendy. I work for a large company where the client list would be proprietary, but the customer name is used all throughout the application. What would you say would be the order of magnitude burden on the application to encrypt the client name? We've got 120 tables and 600 queries in Access, and I'm migrating to SQL Server in the back end.
Okay, and you want to encrypt the client name?
Perhaps.
Okay, so you're saying that they have the client name, but then multiple records under that client.
Yeah.
Correct?
Yeah, loads of use of that. I mean, just in terms of an order of magnitude burden, because that is, I would say, the central table to the application. Generally not encouraged to encrypt something that central.
What do you think, Ben?
Really? I guess I don't understand the question. So are we figuring out with the table and that they have the client's name that shows up in the multitudes in the can you say the question again? The interpreter's not understanding.
Sure.
Yeah.
I have an Access database and I'm migrating to SQL Server on the back end. So historically, this application was run on a local area network, but of course, now that we're distributed, that's not possible. So we're migrating to SQL Server on the back end, but my client considers its customer list to be proprietary. And I have, one table, which is the customer name, list of names, and about 120 tables total and about 600 queries. The question is, what order of magnitude burden on the SQL Server to access data relationship, the data pull, would be imposed if I were to try to encrypt the customer name on these queries? Is there any rule of thumb on this? Because I would say.
Okay, so I think it's just a little magnitude, and the reason being is that when we save the encryption form, then we show the encryption it hasn't been changed or worked on. There's only extra work if it's decrypted. I know that's slower, but each line of code then that's running will be behind a little bit and need a little extra work. But I can show Susan. You know, the last 4 of the Social Security number in that view, in that column. I can save only, quickly read that only, and then avoid the extra work that has to be done to decrypt. That's what slows it down. And I have heard, you know, people say stories that they tend to maybe do 10%, it's 10% slower, or to decrypt, you know, all of the data. So that's a little concerning, but if we use a small bit of data, I don't think we'll notice that percentage. So, you know, what do you guys think?
Yeah, so basically what Ben's saying is if there's only a few rows of data on the form or a single form that you're showing the data on, you won't notice a slowdown of the system. It's only if you've got a real big long list of data that you're showing that it may impact.
Okay. Can the decryption?
Exactly.
Can
Yes,
the decryption
that's what I'm thinking, because I would suggest, especially if you have many, many rows, then you save 2 columns. One column with some encryption, like for example, the last 4 numbers are in one column, and that's read-only. And then the other one is all encrypted, and you have to open up each row and, you know, to see it, instead of doing all of them at the same time, which you don't want to do.
Okay, that's really helpful. And can we decrypt on the front end, on the Access front end, or is the decryption done on the SQL Server?
The decryption is done on the SQL Server side, but from
No,
Access...
never, 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 never. This has been never decrypt on the front end.
Okay.
Always do it at the back end.
Yeah.
Okay.
Only because the key is, you know, the key to everything. We can't lose that control. We have to keep the key. We can't lose control, because then anything can be taken. All the data can be taken.
That's what I
So we have to protect it with the key.
All right.
And that's most important. So we do it at the back end in SQL.
Okay, thank you.
Yep.
Isn't it an option if you need that secure database, that you don't allow any table in the front end and just work with stored procedures and views and show different views to different users or different user groups? That's what I would do if I really need a secure system. What do you think about that?
Yes, you're right. You're absolutely right. Yes, you should use any group. You never want to give permission to any individual. Never, never do that. The individuals
Right.
join the group, and then they come and go. So
Yeah, but I mean, it may be important to hide the tables itself and just show views to whomever in Access, so that Access only works with views, and you have then you have disconnect. You have to save separately, but I think that would be a safe way to do that.
Yeah, I think the only thing I found really with using views as opposed to stored procedures is that within views, you would use the function, and that is slower, whereas a stored procedure can use the keys and the certificates directly, and they tend to work a lot quicker. So if you'd use the stored procedure in a pass-through query, I believe that is quicker than using a SQL view.
Okay,
yes,
thank
and
you.
also this has been one other point to keep in mind. comment before, is that if you use view, everything that's crypted, is going to be used up. That whole column, it doesn't make sense.
Mhm.
So you have to then force the user to request that they want work and what they want to see, each row, crypted, and that's not as safe. So I think it's best to save. The save process is best, and then you can pick, just a limited row, maybe a few rows, and then what's encrypted, all the user, you just don't give them everything. You don't want to do that. And the reason is because you don't want to make a mistake and, accidentally give them a word or something. Like when I go ahead and use views to decrypt, it's like it's never crypted. And if I say something and something gets out there, then someone can just take it. And that can happen. Does that make sense?
Thanks, yes.
I think you're basically saying that it's not as secure with a view, because basically if you're decrypting something in a view, you're decrypting everything.
Can you say that again, please, for the interpreter, for Ben's interpreter? If you what, in a view?
Yes. Were you trying to say that within a view, when you decrypt in a view, it is decrypting all of the data rather than just a particular section, and so it makes it less secure?
Yes, and you don't want to do that. Correct. You want to avoid that situation.
Okay. Any other questions? Just check the chat that we've not missed anything. Oh, I think we're good. Well, thank you very much, everybody, for your time this evening. I
Thank
hope
you,
this has been
Susan.
helpful, and I'll look forward to another meeting with you sometime in the future.
Thank you very much.
Thank you,
You're
Ben.
welcome.
Yeah, thank you very much.
Thank you.
You're welcome. You're welcome. Good night, everyone. Good night, good night, good night.
Good night.
Bye. I think I go to bed now.
Yeah, me too.
I believe you.
Bye-bye.
Bye-bye.
For the code.